Student, today I discuss about steel column base. First, you have to know what is column base. Column base is the base of column that the load from column transferred through this base to concrete block and soil. There are three types of column bases. First one is slab base, second one is cassette base, and third one is Glaze foundation. The slab base we have to use when the load from column is light, and the cassette base we have to use when load from column is heavy or eccentric loading. Glaze foundation is also to be used when load from column is heavy and the column is situated in a soil of low bearing capacity or loose soil. Today my discussion is about slab base and the design procedure of slab base. Here is the figure. There is a column and concrete block, and in between column and concrete block there is a base which is called slab base, and the column and concrete block is connected through a cleat angle, and the cleat angle and the slab base is connected by a anchor bolts. This is the front view and this is the top view. When the column is subjected to only direct loads, the base can be designed by assuming a uniform bearing pressure from below. For small loads, a steel plate alone can be used to transmit the loads to the concrete block or pedestal. Such a base plate is called slab base. Slab base is directly connected with a concrete block by welding or through a anchor bolt. The size of the concrete block depends on the bearing stress of steel, so the size of the base depends on the bearing stress of the concrete block. Now we have to see how the slab base has to be designed. This is the figure, and here L, this is the length of the base plate in mm. Here is the B is the width of the base plate. A, where A is this is the bigger projection of base plate beyond the column in mm, and small b is the smaller projection of base plate beyond the column in mm, and D is the depth of the column section, and B0 is the width of the flange in column. So first step, we have to assume a suitable allowing bearing pressure on the concrete depending on the grade of concrete used. Second, we have to take the area of base plate, capital A is axial load by allowable bearing pressure. This is P by small w. This allowing bearing pressure we have to take 0.25 FCK. If you have to take 15 grade, then it comes 3.75 Newton per mm square. So if the section is square, then we take L is equal to B and we write root over A. If the section is rectangular, then L is equal to take D. This is the depth of column, and in both sides 2A, A plus A, that is D plus 2A. And if you have to take B, then B is how much? B is equal to take B0 plus 2A, B0 plus 2B, B0 plus 2B. So this is, you have to choose the this way we have to choose the area of the base plate. Now we have to choose the area of the thickness of the base plate. As per code of practice 800, the minimum thickness of the base plate is given by Ts is equal to 3W by sigma Bs. This is A square minus B square by 4, which should be greater than Tf, thickness of the flange. And here capital W, P by A1, W is the pressure intensity on underside of base. A1 is the area of the base plate which we have to provide it, and sigma Bs is the permissible stress in slab base, 185 megapascal for all steel. For next video you have to see the numerical problem. Thank you.